We built one up from lists in Python. One of the ones that's really nice on the jump one, it's a good sample example here, is run JSL. So from Python, we can run JSL code, just like from the Python submit allows us to run Python code from JSL. So for here, this one runs through, building a data table from scratch. But for like currency, we currently what the data table supports from Python is you can create any type of column. But in Jump 18, you can only manipulate numeric and character columns directly. That was the focus at this one. We're shooting to add to make sure that the full data table functionality is there from Python to fully interoperate. But getting this whole environment up and all of the interactions and all the pieces, we ran out of time, honestly. But from the run JSL gives us in essence, a backdoor that lets you call the JSL to do things that we cannot do yet from Python, such as setting the column formats or setting the display widths of those columns. So, for example, and then here, part of this example was also to show if you've set a numeric column, which is the default, or we could have done jump data type numeric to set it. But if you've sent a bad value, it'll come in as missing. So we'll run just this portion of it. And so we have for Jill a missing value of what her hourly rate is. And here's the other example. So the other part of this is JSL uses zero-based indexing, but Python users are expecting, JSL uses one-based indexing, but Python users are expecting zero-based indexing, and that is what we've done. But our data table object, this is column, then row. So this is 0, 1, and we can run that, and there we go. It's live. It's set the column. You have direct access to the table. It's not a copy. This is the one and only data table, and it's seen from both JSL and Python. Because here we'll set the widths and the currency on that column. So there we go. That one's a good one. And the other aspect is, so here you see, wanted to show, when we created the column, we can access the column either by name or by index. So say if we do print we print the 0 element of the name column, we get Janet. So you can operate on the name either by the column name or by index. If you want to do something like the Python slicing, where you want to print, let's say, every other one, it needs to be numeric. So if we were to print every other column name, what did I do? List. All right. Isn't we got a column object. The column should have a name. Oh well. Bad example. Do it impromptu. That should give us every other name in the name column. Can't type today. All right. So there's lots of samples. There's lots of stuff here in the scripting index. We've also a couple other special variables that aren't present in JSL is where exactly is this executable located? That might be necessary if you want to run using the Python multiprocessing, where if you just naively call the multiprocessing to parallel process something, you'll wind up launching multiple copies of jump instead of multiple copies of Python. And what you want is have the path to the actual executable, the Python executable. All right, we'll go through, that's the stuff in the scripting index. Let me pull up, got some other samples. Let's see. Say, for example, this is one of them I showed at the keynote in Manchester was you want to pull in a different statistics capability, a hierarchical clustering scan, HDB scan. We can pull that in from, run the clustering. Here's a simple, here we open the jump data table and we create a pandas data frame from, pull from we create a pandas data frame from the data table and a simple assignment of the data. We run the cluster on it and tell it to plot a tree plot, and we'll get the result back as an image. All right, so there we did the hierarchical cluster scan. We've got an image output from matplotlib, and in our log is the results of the clustering. No, this isn't statistics, but the running a Mandelbrot fractal. This sample uses OpenCL, so it's using the power of the GPU to compute in parallel a Mandelbrot fractal that is 2K by 2K. If I run this on the CPU, which is one of the choices, I can run on the CPU or the GPU. It takes 16 seconds to run on the CPU. If we run the script, that's how long it took to create a 2K by 2K Mandelbrot fractal, and we can look at the log. So it took 0.04 of a second to run on my MacBook, running this on the GPU. This is, like I said, it took 16 seconds when I ran this, running the same code, but runs on the CPU. Let's go. One of mine here, where did it disappear? The array handling one is a good one. This is, we can handle data. So this is showing handling data as lists, numpy arrays, jump columns. as well as some of the little details about how some of this interacts. So simple stuff. We create a couple arrays, or an array from the list. That's a Python array class type, or a NumPy array. And create a jump data table. So this one's filled. Columns are empty to start with. And we can set them just as simple as that. Set the column. Come on. There we go. Just click by just assigning the column to the NumPy array or the Python list. Now, one of the things that just got, we created this NumPy array as a float 32. Jump's data table is only doubles numerically. So that doesn't work. That also, it's a bug. It doesn't give you any warning either, and that certainly will be addressed. But we can assign it as type double, and that filled in the values for us properly. And then here, again, we can show the missing value. We can pass none, and this is junk data. We can also test that value for missing, because we can test it the same way would. So 0 isn't junk, so it's false, is NaN, but 1 is junk, and so it shows true. We can set missing value by setting it either using none or math NaN, and that just changed those two to NaN. And then I'd like to point out, make sure exception handling is your friend. Here we go, we'll exceed the bounds. And we caught the error, then give ourselves a message that index is out of range. Print DT gives us just the summary information of the table, columns and rows. We want to iterate across the columns and return the name. We can do that. We can print similarly. The list itself is a summary information. If you have a 1,000,000 row table, you don't want to see that in your print. But if you really do want to see all of those elements, you can print the list in multiple ways. Come on. And like I said, we've already shown that we can show every other element easily enough. With my mouse will actually click on the button. Or we could reverse. So let's see, created a reverse column that put them in different order. We created it with new column and filled it in with the reverse order of the list column. And let's see, we can create a new column, fill it with random values. Now here, we can assign the column to a variable, and that's a column variable, but it's just a variable, because if we assign L1 to col, we are not assigning it to the table. We are assigning the list to